Hi. So we talked about decision trees and we talked about how we learn them and how we look for the best next split. Next, we're going to talk about what is happening with this tree on the test set, right? We have a training set, and that's basically what we used for training, but we're worried that on the test set, we will get performance that is significantly worse. And trees are very flexible, right? So you can basically fit them to data perfectly in the following way. You can create a fully grown tree, and that's one where all the leaves are completely pure, meaning that each leaf either has all positive or all tree has all negative. Each leaf is either all positive or all negative. And such a fully grown tree clearly has zero training error, right? On the training set, it achieves error 0. But if this tree is really very large, then the chances that the performance that is on the training set is not representative. Basically, the tree overfits the data. And so we get a big difference between training set performance and test set performance. Or statisticians would say that trees are high variance or unstable classifiers. So one way that was studied a lot to improve the test error and reduce the overfitting is called pruning. Pruning simply means that after you've built the tree and you minimized the error, you start cutting away some of the leaves. Those leaves that have very few examples are basically being cut down. And so you get a tree that might have a higher training error, but is significantly smaller. And because it is significantly smaller, it's going to overfit less. So that's one very popular way, and there are many different ways for choosing how to prune trees. Another direction for how to improve the performance is bagging. So bagging was invented by Leo Breiman and stands for for bootstrap aggregation. And it's a completely different way to try to reduce the variance of the trees. What we do, instead of pruning the tree, we grow the tree fully, but we generate different subsets of the training data, and on each one of them, we train a decision tree. So now we have many decision trees, each one of them a little bit different because it was trained on a data set that is a little different. And then when we need to predict, we basically use the majority vote over all of these trees. So the attractive thing here is that by taking the vote, we in some sense reduce the variance or the noise in the predictions of the tree, because we are going to predict with the majority. And so if the majority is a clear majority, then we're likely to have a stable prediction that will not overfit. And this method of bagging, specifically bagging decision trees, has been made more sophisticated in something called random forests. And so random forests are basically a method for taking these decision trees and learning a whole forest of trees and then taking the majority over these decision trees. And there are various little tricks that improve over the naive bagging of decision trees. So we'll talk about that in a later lesson. So to summarize, fully grown trees overfit the data. And there are two main ways to reduce overfitting. One is pruning, removing the leaves to make the tree smaller. And the other is bagging, taking a majority vote over many trees that are created using slightly different versions of the training set. I think that that was the summary we wanted to do of decision trees. Hopefully you found it interesting, and we'll continue next time. See you there.